Number 2 question says simplify 9 times 3 raised to power n plus 1 minus 3 raised to power n plus 2 all over 3 raised to power n plus 1 minus 3 raised to power n. And we have the following options here. So our task is to get the correct option. So we will need to recall a very important exponential law that will be very useful to solving this problem. And that law says that if we have something like, let's say, a raised to power x plus y, all right, you have a base that is raised to power, the addition of powers. So how else can we represent this expression? We can rewrite it as a raised to power x times a raised to power y, because they have the same base, their powers will add up, and we are still going to have this. So if we apply this law to what we have in the question, it means that 9 times 3 raised to power n plus 1 can be written as 9 times 3 raised to power n times 3 raised to power 1, right? Minus, do the same thing for 3 raised to power n plus 2, should be 3 raised to power n times 3 raised to power 2 all over. We'll do the same thing for the denominator, and it should be 3 raised to power n times 3 raised to power 1 minus 3 raised to power n. So now that we have this expression like this, what can we do next? If you observe closely, we have a common factor here and also here, and that common factor is 3 raised to power n. That means we can factorize, right? So if we go ahead to factor the HCF, which is 3 raised to power n, we factor it out. So that means if we factor 3 raised to power n, we can use it to divide the expressions here. So 3 raised to power n into 3 raised to power n has gone out, and what we have left here is 9 times 3 raised to power 1. So we have 9 times 3 raised to power 1, which is named as 3, minus 3 raised to power n will cancel out 3 raised to power n, and what we have left is just 3 square all over. We can also factorize the denominator by bringing out 3 raised to power n as the HCF, and say 3 raised to power n into 3 raised to power n has gone out. What we have left is just 3 raised to power 1, which is 3, minus 3 raised to power n cancels out 3 raised to power n, and what we have left is 1, because if they divide themselves, you have 1. Alright, so we discovered that 3 raised to power n appears both at the numerator and at the denominator, so we can simply strike it out. They will divide themselves and it will be eliminated. And so the expression I have left is 9 times 3 minus 3 square on the numerator and 3 minus 1 on the denominator. So if we go ahead to evaluate this, 9 times 3 is 27, and 3 square is 9 all over 3 minus 1 is 2. So we'll say 27 minus 9 becomes 18 over 2, and 18 divided by 2 is 9. And so 9 is the answer to this question. Therefore, the correct option here is B.